Good morning, students. Good morning to all. In last class, we are discussing about alcohols, phenols, and ethers. We are already completed the classification of alcohols, phenols, and nomenclature of alcohols and phenols, and also ethers. And again, we discussed about the preparation of alcohols. Alcohols can be prepared by different methods. See, important one you have to study is from alkene. From alkene, alcohols are prepared by two methods. One is hydration in presence of an acid, which is called catalyzed hydration of alcohol by an acid. And you studied mechanism also. In mechanism, three important steps are there. Repeatedly you have to write and you have to practice. Then you studied from diborane and alkene. Trialkyl boron is formed, and that is on oxidation with hydrogen peroxide. According to anti-Markovnikov rule, the alcohols are formed. And again, alcohols are prepared from the oxidation of aldehydes and ketones. Not oxidation, it is nothing but a reduction of aldehydes and ketones by using strong reducing agent like lithium aluminum hydride, sodium boron hydride, and as well as the noble catalyst like platinum, palladium, etc. Again, dear students, you also studied preparation of phenol. Phenol can be prepared by four important methods. Phenol can be prepared by chlorobenzene when it is treated with NaOH in a drastic condition, nearly 623 Kelvin temperature and nearly 300 atmospheric pressure. Again, phenol is prepared from oleum. Again, phenol is prepared from primary aromatic amine, that is nothing but aniline. From aniline also we can prepare. And again, you studied the manufacture of phenol from cumene process. Cumene is nothing but isopropyl benzene. And on class itself, we told to you many times, it is asked in your annual examination. Preparation of phenol from cumene. Cumene is just oxidized, and finally it is on acid hydrolysis you will get phenol. Are you clear? Okay, again you studied the physical properties of alcohols and phenols. In physical property, particularly you have to study the boiling point and solubility. Alcohols are having more boiling point than similar molecular mass of particularly hydrocarbon, haloalkane, and ether. It is due to alcohols are formed, they are having a stability. Alcohol can form or they can have a stability to form intermolecular hydrogen bond. Are you clear? See, all these concepts we discussed very clearly. And in last class also we discussed about the chemical reactions of alcohols and phenols. That video is interrupted and that class is cancelled. Today we shall discuss about the chemical properties of alcohols, particularly acidity of alcohols and phenols, and we shall study some chemical reactions. Okay, see, Whenever the class we are going to inform in previous day itself. See, many of you are watching on live class. So those who are some shows laziness, particularly have to watch the class at the live only, at the scheduled time only. Repeatedly, if you want to see again, you have to practice it. Write down the notes, and today only I will send you the notes of alcohols, phenols, and we shall study the chemical reactions of alcohols. Okay, chemical reactions of of alcohols. See, alcohols which has a general formula ROH. ROH. So you can find here two types of bond. One is oxygen to hydrogen bond, oxygen to hydrogen bond, and another one is this alkyl group, and that is nothing but carbon to oxygen bond. Carbon to oxygen bond. Say this will be separated. Alcohols forms two types of chemical reactions. One is breaking of O to H bond, breaking of O to H bond, breaking of O to H bond, hydrogen will be separated. And it also forms another type of chemical reactions where C2O bond breaks and will cleave off. Most important point here. And more than that, alcohols can act as a nucleophile as well as an electrophile in chemical reactions. Are you clear? Okay. So, two types of chemical reactions we can find. One is the breaking of oxygen to hydrogen bond. Another one is breaking of carbon to oxygen. Are you clear? Okay, we shall study the chemical reactions of alcohols with chemical reactions of alcohols with metals. See, when it reacts with alcohols, reacts with sodium first one. With sodium metal. With sodium metal. See, alcohol ROH. So when it reacts with sodium metal, just to see, and we will get ROH plus hydrogen gas. Just balance this equation, so that one is 2Na, 2ROH. Alcohols react with active metals like sodium, hydrogen gas is liberated. Are you clear? See, take for example, particularly it is there in your textbook also. See, when tertiary butyl alcohol, CH3, tertiary butyl alcohol, when it reacts with element aluminium. So we will get six molecules of tertiary butyl alcohol. Tertiary butyl alcohol. See, when it reacts with active metal aluminium, so we will get tertiary aluminium butoxide. Say 2 times CH3, again CH3, this is CH3 and O, which is nothing but see here aluminium thrice. See, this is nothing but tertiary aluminium butoxide, and again 3 molecules of hydrogen gas is liberated. 3 molecules of hydrogen gas is liberated. From both the reaction, we conclude that hydrogen gas is liberated. It indicates that alcohols are very good acids. Alcohol behave as an acid. Are you clear? Alcohol reacts with active metals like sodium and aluminum, and we will get sodium alkoxide. So this is nothing but 2R and H2. And concentrate this reaction. So this is nothing but tertiary butyl alcohol. Its common name. When it reacts with aluminum, and we will get, see, trimethoxy, tertiary trimethoxy aluminum. Just we can balance here 2 and here 3. Again, hydrogen gas is liberated. So these two reactions shows that alcohols are acidic in nature. Okay. Then we shall study the chemical reactions of phenol. See, chemical reactions of phenol with metals, particularly sodium, with the sodium. See, phenol reacts with sodium to Na. Again, these two molecules of phenol. Phenol reacts with the sodium metal. See, what are the product form? Let us see. See, phenol reacts with sodium metal. We will get sodium phenoxide. See, phenol. This is nothing but ONA, which is called sodium phenoxide. Sodium phenoxide. Again, we can find the release of hydrogen gas. Hydrogen gas is liberated. Can you see hydrogen gas? Hydrogen gas is liberated. Are you clear? So, when phenol reacts with sodium metal, we will find sodium phenoxide. So, sodium phenoxide is nothing but, again, it liberates hydrogen. So, therefore, phenol also acts as an acid. Are you clear? Okay. Then, see again, when phenol reacts with sodium hydroxide, sodium hydroxide, same reaction, we will get what? Again, sodium phenoxide. So these two reactions indicate that hydrogen gas is liberated. Therefore, phenol is acidic in nature. Okay, we shall continue our discussion. When, say, RO minus, which is nothing but an alkoxide ion, when it reacts with water molecule, so this is nothing but water. I am going to write like this. So, this hydrogen of the water, hydrogen atom, which is absorbed by alkoxide ion. So, this is nothing but water. So, this indicates that, so you will get ROH plus OH minus. This indicates that water is more acidic and alcohol is less acidic. So, we have to remember alcohols are less acidic than water. Are you clear? Alcohols are less acidic than water. Okay. Then you have to compare the acidity of alcohol and phenol. We shall compare now acidity of alcohol and phenol. See, water is more acidic than alcohol. So therefore alcohols are less acidic than water. See, this reaction indicates. Okay, now we have to study the acidity of phenol. We shall discuss about acidity of phenol again. See, acidity of phenol. acidity of phenol. Okay, so we discussed about the acidity of alcohol. Now we should study acidity of phenol. So what is the structure of phenol? So this is nothing but the structure of phenol. See, OH, just I will separate it, right? So on oxygen atom you can find a lone pair of electron. Okay, so here the electron is donated and this will become ionized. So we will get a resonance structure. The next resonance is, say, here it is minus and this bond will come here and here it is a double bond and partial positive charge on oxygen atom and this is nothing but H. Are you clear? So explain the acidity of phenol. You have to write neatly the structure. Resonance structure. See now next, so this chart moves here and you will get the next resonance structure as, so double bonds are, and that is nothing but minus, and this is double bond again partial positive character and this is nothing but H. Again next resonance you can find, so this adds here and you will get next resonance minus charge here and bond it here and this is nothing but a double bond, oxygen atom partial positive charge and this negative charge again pairs here. And then we will get the original phenol. See, this is the phenol. Again, due to resonance, so this is nothing but resonance hybrid. These are nothing but the resonance hybrid. So resonance. And so ionic character of this O to H bond is weaker as electron is absorbed by the sp2 hybridized carbon. So benzene is electron rich. You studied this. As sp2 hybridized carbon is more electronegative. Again, this is again paired here. So therefore, O to H bond ionizes easily. And hydrogen atom can easily remove. So therefore, phenols are highly acidic than alcohol. And phenols are strong acid even than water. You can easily explain by the resonance. Explain acidity of phenol if it is asked. So you have to write this resonance structure. One point you have to write, the oxygen atom which is attached to sp2 hybridized carbon of the benzene ring. See, here electron, it donates the electron to the benzene ring. Then oxygen to hydrogen bond ionizes easily. Hydrogen can be easily removed. As more and more hydrogen removes in the solution, acidic strength automatically increases. So therefore, phenols are highly acidic than alcohol. You have to explain the resonance. See which is there on the board. You studied how in first piece itself, you studied how to write resonance. Resonance hybrids are more stable. Okay, this is nothing but the acidity of phenol. Then we shall discuss next part, which is nothing but the comparison of compare the acidity of alcohols and phenols. See, acidity of alcohols and phenols. Now I am going to write, see this is nothing but a primary alcohol, ROH, and this is nothing but a secondary alcohol, see ROH, CH here, and it is nothing but a tertiary alcohol, R dash, R double dash, tertiary alcohol, OH. See methyl group, R is nothing but a methyl group, R is nothing but a methyl group. or even it is an ethyl C2H5. See, these methyl or ethyl groups, they are electron donating group. They are electron donating group. See, as you can compare the acidic strength of alcohols, primary alcohol, secondary alcohol, tertiary alcohol. So in tertiary alcohol, see, it has its strength decreases in the order. It decreases in the order. So like this. Are you clear? So here acidic strength only one. Acidic strength only one alkyl group is there. Here two alkyl groups. Alkyl groups are electron donors. Electron donors. Acidic strength decreases as follows. So it is there in your syllabus. Just you have to compare and you will get some CET question or one mark question you will get. Okay, we can easily answer. Okay, this is nothing but the comparison of the decreasing strength of alcohols. So this is nothing but tertiary alcohol, and this is nothing but a secondary alcohol, and this is nothing but a primary alcohol. As electron donating groups are there to the carbon atom, then hydrogen atom is completed. So release of hydrogen atom in the solution is less. So therefore acidic strength automatically decreases. Okay. Then we shall compare the phenol and phenoxide. Phenol and phenoxide ion. See, this is nothing but phenol. Okay. OH, and this is nothing but phenoxide. It is nothing but phenoxide, O minus. Phenoxide. See, among phenol and phenoxide, which is stable? Phenoxide ion is stable. It is stable. It is again due to resonance. We can easily write the resonance. See, as a negative charge is here, again known pair of electrons are there, and again, so this oxygen is bonded to sp2 hybridized carbon of the benzene ring, and again resonance is possible. As the negative charge electron cloud is more on phenoxide ion, among phenol and phenoxide ion is more stable. Are you clear? Okay. On phenol, if any electron withdrawing groups are there, then automatically acidic strength decreases. If suppose an electron donating groups are there, electron donating groups like methyl, ethyl, then automatically the acidic strength decreases. Don't get confused. As electron donating groups are there, substitute electron donating groups are there, the acidity decreases. Electron withdrawing groups are there, electron withdrawing groups like NO2 on phenol, then acidic strength increases because oxygen to hydrogen ionization can take place easily. Electrons are not on the hydrogen atom, it is towards the benzene. So I will repeat again. See, electron withdrawing groups are there on phenol. See, on phenol. See, electron withdrawing groups. So this is nothing but phenol. Electron withdrawing groups like NO2 is there. So electron withdrawing groups are there, then automatically partial double bond character, and you know this resonance. Then electron cloud on hydrogen atom, this bond will be weak, very weak, and it can easily ionize. So therefore it is a strong acid. Are you clear? Okay. If electron donating groups are there, electron donating groups are there. Then the position is there. Electron donating groups are there. As the group itself it can donate electron, and in oxygen atom electron clouds are more. Oxygen and hydrogen are tightly held. Then acidic strength decreases. Acidic strength decreases. That point you have to remember. Are you clear? I will repeat again, dear students. On phenol, if electron withdrawing groups are there, then acidic character increases. In phenol, if electron donating groups are there, then acidic strength decreases because oxygen and hydrogen are tightly held. That's all. Simple enough. So you can easily judge by pKa values. So some of the metanitrophenol, paranitrophenol, some examples are given there, and you will get some CET question. As pKa value is very less, they are strong acid. That's all you have to do. Okay? Yes. Then we shall go for next. We studied in detail the acidity of alcohol and phenol. Acidity of alcohols and phenols. Are you clear? So I will repeat again some of the points which you have to remember. Alcohols are less acidic than water. One point you have to remember. Another one. Compare different types of alcohols, primary, secondary and tertiary. The acidic strength decreases in the order tertiary, secondary, primary. So which is there in your textbook. Then see, as compare alcohol and phenol. Phenol is more acidic than alcohol. Okay. Even then in alkoxide ion also. It is due to resonance. See, oxygen and hydrogen bond are tightly held in phenol. So during resonance, the sp2 hybridized carbon and the oxygen, electron cloud of the oxygen atom attract towards the carbon atom of the benzene. Then oxygen and hydrogen are loosely held. Ionize easily. Hydrogen atom can go out in solution. It can enter in solution. Automatically, the acidity increases. Are you clear? It can be well explained by the resonance. Okay. Then we compare the stability of alkoxide ion and phenol. That means not alkoxide ion, phenol and phenoxide ion. Phenoxide ion is more stable than phenol. Phenoxide ion is more stable than phenol. Okay. Then again you study. See, the comparison of acidity of phenol in the presence of electron withdrawing as well as electron donating. When electron withdrawing groups are there, such phenolic derivatives are more acidic. Either it may be in ortho, meta, para. Slight difference is there. If suppose electron donating groups are there on benzene, on phenol, then acidic strength decreases. Are you clear? So oxygen and hydrogen atoms are strongly held. If electron groups are there, electron withdrawing groups are there, oxygen and hydrogen atoms are loosely held. The electron cloud of oxygen atom comes more towards the benzene ring of the carbon. Okay. So I will stop my discussion regarding acidity of alcohol and phenol. Okay. I think you are understood. Now we shall study other chemical reactions of alcohols. That is, we shall study first one, esterification. Esterification. See, when alcohols reacts with carboxylic acid or anhydride or acetyl chloride. Okay. Therefore what? Ester. In presence of concentrated, small amount of concentrated sulfuric acid. This particular reaction is called esterification. Particularly, alcohol reacts with carboxylic acid in presence of concentrated sulfuric acid. On heating, they form ester. Are you clear? They form ester. This reaction is called esterification. Shall I write some equation? See, instead of carboxylic acid, alcohols can also react with anhydrides. CH3CO, CH3CO, which is bridged with oxygen atom, bonded with oxygen atom. They are called anhydride. Again, acetyl chloride, COCl, CH3COCl, acetyl chloride. There also it forms an ester. This particular reaction is called esterification. We shall study some general equation. See, alcohol, ROH. Okay. When it reacts with carboxylic acid, HOOCR, which is nothing but a carboxylic acid. In presence of H2SO4, just on heat. And we will get an ester. See, here this water molecule is here. RCOO, R dash, and ester is one. By the removal of water molecule. And this particular reaction is called esterification. What are esterification? Give an example. Define esterification. Or what is esterification reaction? Give one general example. You have to give example. See, instead of we have to use carboxylic acid, you can use acid anhydride. So this is nothing but acid anhydride. CH3CO, which is bonded by oxygen atom. Are you clear? This is nothing but an acetic anhydride, and this is nothing but anhydride. Generally, we can write CH3CO twice O also. When it reacts with an alcohol, ROH. See, which is also a reversible reaction. Same in presence of amino acid, H2SO4. So we will get see RCO R dash. Then here it is nothing but CH3. CH3. Then plus again CH3COH. Carboxylic acid is formed. Are you clear? When anhydride is used, in place of anhydride, you can take acetyl chloride plus COCl, which is a particularly acetyl chloride. CH3COCl. So at that time, you have to use a base pyridine. You have to use a base pyridine. Here, again we will get an ester RCOOCH3 and removal of HCl gas. So this gas HCl acid is absorbed by the base pyridine. See, always these reactions are reversible in nature, as water molecule is produced again, and therefore we have to use concentrated H2SO4. Are you clear? So when the alcohol reacts with acetyl chlorides, then you have to use a chemical pyridine in order to absorb the produced HCl, hydrochloric acid. Are you clear? So it is nothing but esterification reaction. Are you clear? Even phenol can also answer. When phenol reacts with the carboxylic acid, here the benzene ring oriented esters are formulates are. So particularly when salicylic acid reacts with salicylic acid, see reacts with anhydride, so we will get aspirin. We will get aspirin. I am going to write this equation. See, shall I write? I will repeat again. In esterification, according to your syllabus, esterification not only with carboxylic acid, it is also with anhydride and as well as acetyl chloride. See, one more question you may get in CET or any competitive exam. See, when alcohol reacts with acetyl chloride, the base pyridine is used. Give reason or why. To absorb alcoholic acid. That's all. And all these reactions are reversible reaction. And here, whatever the water form, it should be removed in the reaction. And that is nothing but esterification. Any particular example also you can write. So these are the general examples. One particular example I am going to write. Say C2H5OH, which is nothing but ethyl alcohol. Ethyl alcohol. When ethyl alcohol reacts with acetic acid, CH3COOH, acetic acid. In the presence of concentrated H2SO4, just we have to heat. Then we will get say CH3COOC2H5. So we will get thimethyl ester and removal of water molecule. So which is nothing but a fruity odor. We get fruity odor. So this reaction you have to perform in laboratory. When college starts, we shall see how to perform it. So you have to take about 1 or 2 ml of ethyl alcohol in a clean test tube. Again, you add 2 to 3 ml of ethyl alcohol and carboxylic acid. Add 1 or 2 drops of concentrated sulfuric acid. Just you have to heat. So heat slowly, then again heat, and just we have to heal it, we can get the odor. And you can also pour the whole solution in a beaker which contains sodium carbonate, and just you will get a fruity smell. So this particular reaction is called esterification reaction. You can easily perform in the laboratory. It is there in your syllabus and you can easily perform. So this is called esterification. A particular example. Okay, when phenol reacts with see, instead of alcohol, we are going to get phenol. Again, same we will get CH3CO will be add to that. So that is nothing but aryl esters we will get. That's all. Again, particularly you have to study one example. So which is nothing but the you have to study. So which is salicylic acid. This is nothing but salicylic acid. See, COOH, OH, and this is salicylic acid. When salicylic acid reacts with anhydride, CH3CO twice O. So this is about acidic anhydride. And we can say CH3. So benzene ring, again COOH, and this hydrogen is replaced, and you will get OCOCH3, and which is called aspirin. And plus we will get CH3COOH, which is acetic acid. So this equation we have an example. What's the name of this compound? Salicylic acid. When salicylic acid reacts with acetic anhydride, say we studied in last reaction, acetic anhydride, right? And we will get a chemical aspirin. Are you clear? So aspirin is a drug. It's a tablet. Generally, we call this as generally all tablets are called drugs. So which is used to prevent body pain and temperature. Aspirin, aspirin is for when salicylic acid reacts with acetic anhydride, we will get what? Aspirin. So this particular example we have to, is there in your textbook? So sometimes you can ask for annual examination. Are you clear? Okay. Then we shall continue our discussion. Chemical reactions of alcohols, then esterification over. Esterification is over. Are you clear? Are you clear? So this is called esterification. And we shall continue in the next class. Are you clear? So dear students, today we discussed about many chemical reactions, particularly acidity of alcohols, phenol and phenols. And you have to compare to alcohol and phenol. Then you studied esterification. See, esterification reaction when this alcohol with carboxylic acid. So we will get an ester in the presence of concentrated HKSO. Again, formation of aspirin is there when salicylic acid reacts with acetic anhydride, aspirin is formed. Okay, I will stop here. Dear students, in organic chemistry, simple chemical reactions are there. Just we will explain and write on the board. Again, I will send you the notes. Very clearly, you have to copy it and practice it. That's all. And again, I am going to tell you, watch live class only. Watch live class. Any comment, be comment, even in personal WhatsApp. So even for the notes or any questions you have, WhatsApp. Are you clear? Okay, thank you.